Looking at numbers 5 and 6, these are similar to 1 through 4, except for with these we might end up with a weird situation where we get like a 0 equals 0 or a 2 equals 4, and we have to know what that means. So we can do the same idea as what we were doing in those previous problems, and I would probably try to either cancel out the x's or the y's here. Now the top one's a little bit tricky just because of how it is set up. Notice this one's y and this one's x and this one's x, that one's y. I'm going to reorder the top one so the x is first and then the y is second. So this negative goes with the x, negative 2x. And then the y is positive, so it'd be plus y equals negative 2. And then the bottom one I'm just going to leave as is. And then we can go ahead and use our elimination method that I think most people prefer. So if I'm trying to eliminate one of the variables, I can pick which variable I want to get rid of. So let's say I look at the y's and I want to get rid of the y's here. This is negative 4y. I would want this to be positive 4y. So I'm going to have to take this top equation times 4. Now when I do that, I distribute it to all of the pieces. So I get negative 8x plus 4y equals negative 8. And the bottom equation, I just leave the way it is. And what happens here that didn't happen in those first 4 questions is when I add these together, not only do the y's go away, the 4y and the negative 4y, but this one also goes away. We end up with nothing on the left-hand side. This is 0, that's 0, so we get 0 equals. And over here, these actually cancel each other out and give me 0. So this is always a true statement. 0 is always equal to 0. So there are infinite solutions here. If it was one of the cases of 1 through 4 and you solved it, then it would be one solution. And what you got for an answer, that is your one solution. Okay, when we look at this one, same idea. Let's do this one using that substitution method to get some practice. So you could either solve for y here, but then I'm going to have fractions, which most of you don't like. So I'm going to take the bottom equation, and I'm going to get y by itself. So I'm just going to write it as is first. And to get the y all by itself, I would subtract 5 from both sides. So I just get y equals negative 4x minus 5. And because I took that from the bottom equation, you want to plug into the opposite equation. So I'm going to plug into the top equation. And you want to plug in for the y. So let me just write it, and then we'll plug in. So I'm plugging into here for the y, so 4 parentheses, and instead of y, negative 4x minus 5. So this is our 4y equals 6 minus 16x. And then we're going to solve for x. So here we distribute next. So I get negative 16x minus 20 equals 6 minus 16x. And here if I add 16x to both sides, it's going to cancel on both sides. And you don't want to just go, oh, no solution or infinite solutions right away. Finish it out here. On the left side we get negative 20, and on the right side we get 6. Those are never equivalent to each other. So up here, these are always equivalent to each other, infinite solutions. When they're not, when we get a statement that is never true, then it is a no solution.